So what if I'm multiplying these? Well, that's just to distribute. Remember, we are going to distribute and then combine like terms, just like the negative. So again, we do the first one, multiply 1 times 5. So 1 times 5 is 5. We do 1 times negative 4, which is negative 4i. We are done with that part, and then we're going to jump from negative I to times that 5, so negative I times 5, which is minus 5i. And then the last thing is negative I times minus 4i, which turns into a positive 4i squared. So this is just like distributing with x's, except there's one little caveat at the end. So if I simplify this, we have 5 minus 9i, and then plus 4i squared. But we have to think back that I squared is equal to negative 1. This is a big thing that we need to know. So we're going to replace that I squared with a negative 1. So we will be substituting this in order to get a real part and an imaginary part. I don't want I squared or I to the third or I to the fourth. I just want I. So this simplifies to 5 minus 9i, and if I put that as a negative 1, it's just making it the opposite. So positive 4 turns into negative 4, because it's saying the opposite of whatever this number is. That's what multiplying by negative 1 does. And then it just is going to combine like terms for the end thing. So 5 and negative 4, which is a positive 1, and minus 9i, which gives me that final answer in standard form. So our last problem today is division, which actually is all about multiplying. So division in complex world or square roots, we always end up doing multiplication. So I'm going to put these in parentheses. Now we're going to have to multiply by 1. So today we will multiply by 1. And it's going to be a special one. Let me rewrite that 1 here. I'll just write it like that. We're going to rewrite it as or multiply it by 1. And we're going to be using what's called a complex conjugate. So we're going to use something called a complex conjugate. Basically, a complex conjugate is if we look, well, let's say the complex conjugate of the denominator, to be specific, denominator. A complex conjugate. So if I look at the bottom of negative 3 minus 4i, its complex partner or pair turns into negative 3, and we're going to change it to plus 4i. This negative stays the same. So that's the same. The only thing that changes is whatever's in between the real and the complex part for that. So that goes from negative to positive. We're going to be multiplying this to both the top and bottom. And that is a legal math move because we are multiplying by 1. Anytime I multiply by 1, it doesn't change the actual value. Because if I take 100 times 1, it's still 100. In this case, this 1 is just a very interesting looking 1, and that's why it's important in math. We use multiply by 1 a lot. And we actually add 0 as well, which adding nothing, it doesn't add more value. It just makes it look different, which is okay. So now we have a multiplication problem on top and a multiplication problem on the bottom, which the bottom one is actually very, very nice. So let's distribute out the top. So negative 5 times negative 3 is 15. Negative 5 times positive 4i is negative 20i. Switch it up. 3i times negative 3 is minus 9i. And then a positive 3i times 4i, which is positive 12i squared. The bottom, if you actually distribute it out yourself, which you should try, you should get 9. And then the insides actually cancel out, and we're just left with negative 16i squared. Now, why would we use these complex conjugates? Well, when you multiply this out, you get the we'll have a negative 12i and a positive 12i, which will cancel out. And this turns into a real number. So when we do this, let's combine stuff. And again, remember, this part right here is, in fact, that is negative 1. So we're going to put this as 15 minus 12. Instead of adding 12, we're subtracting 12, which gives me a 3, and then minus 29i all over. And again, the bottom is that same way. This is also a negative 1. So that turns into positive 16. So it'll be 9 plus 16, which is in fact 25. Now, I can write this as a standard form complex number. So basically, this 25 will go to both the 3 and to the negative 29. So this is just 3 over 25 minus 29 over 25. And we're just going to put the I outside. That's okay. It's multiplying by all of this. And this would be that A plus BI form, that standard form that we need here. So I want you to try this one. This one's a little bit easier. Again, we still have to find the complex conjugate of the denominator. The top just multiplies out easier. So pause it. I will have an answer shortly, but you should try it first and pause it. So if you tried it, you should have got 2 over 13, which is 4 over 26. That simplifies, and then 20 over 26i, which simplifies as well. You should always simplify as well. You're in pre-calculus, so I'd expect that.